there's a topic, they call it limit and continuity. Okay, so they are, let me write it, limits and continuity. So this limit is is how to determine how far a particular expression can go. When you hear the word limit, how far can it go? That's the concept of limit. And will it stop there or will it continue? Or if you give you a particular variable, will the variable stop at the particular limit or will it be a continuous variable? That's the limit and continuity. So you have some basic rules, and limit is written like this: lim x tends to a of, let me say, of f of x. S tends to a of f of x. So that is a variable. That variable can be 1, can be 0, can be 2, can be -2, can be 4. It depends. That variable can be any number. Okay. So the limit of FFA now, this can be written as f of what? Meaning anywhere you see s, here is x now. This one meaning s tends to a, meaning s approach a. I will fix a in place of x. So if I fix a here, my a is x now. My s is a, here become f of a. That is the result. Limit of f of x as s tends to a becomes f of a. So that's how limit goes. Then we have conditions for limits. There are some rules on conditions for limits. Number one, rules in limits. Rules in limits. Number one, 0 is over 0 is undefined. 0 over 0 is undefined. That means you cannot have 0 at the denominator. 0 is not allowed. 0 is not allowed at the denominator. Okay? You're not allowed to have 0 at the denominator. But you can have 0 at the numerator. I can have number 2, 0 over 3 is 0. But your concern should be the denominator should never be 0. Do you understand? That should be your concern. The denominator should never be 0. Okay? So write that.
Yes.
Write it.
No.
Okay. Then number 2, if you have the lim, we call this one special limit. The limit of x tends to 0 of sine x over x, the result is always 1. Anytime you see sine x over x, the result is 1. Okay? Maybe if you have lim, for instance, a limit of x tends to 0 of sine 2x. So if the numerator is 2x, denominator should also be what? Be 2x. The result is 1. So whatever you have here, after the sign should also be present in the denominator. You can see here is x, here is also x. Whatever you have after the sign should also be at the denominator. That's the only condition the result can be 1. Or otherwise it's not. So if not 1, if not the same, you cannot be the answer cannot be true. It must be the same after the denominator. So write that too.
I'm done.
Okay. And we also have number 3, where you have lim x tends to infinity. This symbol here is called infinity, or 1 over x to the power n. The result is 0. This symbol like this is called infinity. That's what it's called. It's called infinity. So anytime you have a situation like this, we are going to, there are other one, but we are going to stop here because they don't set that much maybe they will set 1 or 2. That will be all.
I'm done.
Okay. So look at this question. This is it's a find lim. It's a evaluate lim x tends to 2 of x squared minus 4 over x minus 2. We have option. Option A is 2. Option B is 4. Option C is 6. Option D is 8. Option E is 10. So write it.
I'm done.
Okay. So if I want to solve this, I've told you, meaning anywhere you see x, you should put 2. So let's see what we have. If we put 2, where we find x. Look at the question. We have lim x tends to 2 of x squared minus 4 over x minus 2. So this one means that x tends to 2, meaning anywhere you see x, put 2. If that should happen, what are we having? We are going to have a 2 square here minus 4 over 2 minus 2, which is what? 2 squared is 4 minus another 4. 2 minus 2 is what? Is 0. 4 minus 4 is what? 0 over 0. Now look at what we said earlier. You can see, I told you this is not what? 0 over 0 is not what? It's not defined. Are you saying it? Our denominator is not, 0 is not aligned in denominator. Or what you're having here now, we are having 0 at the denominator, which is wrong. It means that you cannot simplify this equation like this. And beside that, we don't have 0 as the option, 0 over 0 as the option. Are you saying it? Meaning the approach we took is not correct. Number one, we violated the rule already by leaving the denominator at 0. Denominator can never be 0. So how do you tackle a situation like this? So we have lim, let's solve the question correctly now, of x tends to 2, x squared minus 4 over x minus 2. Now, we know that 4 is a perfect square. So if 4 is a perfect square, we write it as lim x tends to 2 of x squared minus 2 squared over x minus 2. Because 2 squared is 4. So that makes it a perfect square. 4 is a perfect square. Now, if you look at what we have here, that's the difference of 2 squared. If you have a squared minus b squared, can be written as a minus b and a plus b. So if you're having x squared minus 2 squared, we'll be written as what? X minus 2 and x plus 2. That's what it means. So if I put it on the limit, I'm going to have lim x tends to 2. So in place of x squared minus 2 squared, now will be written as what? X minus 2, x plus 2 over x minus 2. You see it? So that x minus 2 will cancel x minus 2. What are we left with? We are left with lim x tends to 2 of x plus 2. So as it is now, anywhere I see s, I can substitute 2. Anywhere I see s, and I can put 2. If that should happen, what am I going to have? I'm going to have lim x tends to 2 of 2 plus 2. Anywhere I see s, and I'm putting 2. What is 2 plus 2? The answer is 4, so which is option B. You see that?
Yes, sir.
So write it.
I'm done.
Okay. So that is a way to solve a limit. Let me look for another question. A limit. So say evaluate lim x tends to 1 of x squared minus 2x plus 3 over x minus 1. No, 3s plus 2. Let's say it's 3s plus 2 minus 3s plus 2 minus 3s plus of 2.
I'm
Okay.
done.
So if you try it again also by putting the denominator as anywhere I see s put 1 now, for instance. So anywhere I see if I put 1, I'm going to have what? 1 square minus 3 brackets 1 plus 2 over 1 minus 1. Which 1 square is 1. 3 times 1 is 3 plus 2. 1 minus 1 is what? Is 0. If you add up the denominator, also have 0 over 0. You can see it's not allowed. You cannot have 0 at the denominator, but you can have 0 at the numerator. You understand? A 0 is not allowed at the
Yes, sir.
denominator. So for that reason, this is not the right approach to solve it. Now, let's solve the question thoroughly now. So let's say we have lim x tends to 1 of x squared minus 3x plus 2 over x minus 1. Now, if you look at the numerator, it's a quadratic factor. It's quadratic. Anytime you have an x squared in an expression, that's a quadratic expression. So numerator is quadratic. So you ask yourself now, how do we factorize the quadratic equation on top? To factorize it, you are going to think of two numbers. If you multiply the two numbers, you have positive 2. If you add the two numbers, you have if you multiply the two number, you have positive 2. If you add the two numbers, you have negative 3. Which number can do that for us? If you multiply, you have positive 2. If you add, you have negative 3. Which number have that ability?
If
You multiply, it will give you plus 2. If you add, it give you minus 3.
minus 2 plus 1.
No, it's minus 2 minus 1. So minus 2 minus 1 is the factor. So let's fix them. I will use the minus 2 minus 1 to replace minus 3. So I'm going to have lim x tends to 1 of x squared minus 1x minus 2x plus 2 over x minus 1. You see that? So what I'm going to do now is I'll bracket the first two. So I'm having lim x tends to 1. Who are the first two? X squared minus 1x. I also bracket the last two. 2x minus 2 over x minus 1. Now let's ask ourselves, what is common from the first bracket? I'm having lim x tends to 1. What is common from the first bracket is x. So let's bring out x from the first bracket. So if I remove x from the x square, I'm left with 1x there. If I remove x from the 1, you're left with 1 minus. Let's check what is common in the second bracket. Second bracket, 2 is common. I'm left with x minus 1 over x minus 1. You see that? So now that I'm factorizing, I will take the two brackets as 1. I'm having lim x tends to 1. The two brackets are the same. I will just take it as 1, x minus 1. I will take those outside the bracket, x minus 2 over x minus 1. You can see x minus 1 can cancel x minus 1. We are left with lim x tends to 1 of x minus 2. So NUSCS now you put 1. So if that should happen, what are we going to have? We're going to have, so now implies 1 minus 2. And 1 minus 2 is what? Is minus 1. So our x is minus 1. Understood? So if you understand, or you have any question to ask me, ask. But the contrary, you can write it.
I'm true with this, sir.
Okay.
I'm done.
Okay. So that is the concept of solving limits. So let's try another example, example 3. Example 3. Let's say I've solved lim x tends to -1. We have x squared minus 4x plus 5 over x minus 2. Let's assume we have this situation.
I'm done.
Okay. So you can see, so you can first of all try it. If the denominator will give you 0. If the denominator does not give you 0, that is the answer. No need to solve. So let's try to put s as 1 first and c -1 and see. So we're going to have -1 square minus 4 bracket -1 plus 5 over -1 minus 2. So where's -1 square is 1. Minus 4 times -1. -4 times -1 give us plus 4 plus 5 over -1 minus 2 is what? Is -3. So what are we having on the top? The top will give us what? Which is 10 minus 10 over 3. So this is just the answer. In as much the denominator does not give 0, that is your answer. Do you understand?
Yes, sir.
In as much as the denominator does not produce 0, that is the result for the solution.
I'm done.
Okay. So this is how to solve limit. Let me give you one to try. Let us say lim x tends to 3 of x squared minus 9 over x minus 3. Try that. I'm coming. Just give me a minute. Are you done?
No.
Okay. So you know 9 is a perfect square, B. So you write 9 as 3 raised to power 2. 9 is a perfect square. So you should be able to apply the concept of difference of two square to get the answer correctly.
The answer is 6.
Yes, it's 6. You're right. The answer is 6. Answer is 6. So, okay, let's assume they gave us lim x tends to 4, square root of x minus 2 over x minus 4. So first of all, try it if we give 0 or not. Now, if I put 0 as in place, if I put this 4 now in place of this 4 now, in place of x now, what are we have? Is it not 4 minus 4?
Yes, sir.
And that denominator is already 0. If I put 4 in place of this square root, what is the square root of 4?
So,
Which is we are now having 2 minus 2, which is also 0. That means we cannot solve like that. So when you have a situation like this and you have a surd, which is the square root, you have a surd, whether the denominator or the numerator, you have to rationalize the expression by looking for the conjugate. So first of all, we rationalize this expression. I'm going to have lim x tends to 4, which is root x minus 2 over x minus 4 times. I want to rationalize now. I'm rationalizing the numerator. Let me write it here. Rationalize numerator. Because the surd is at the numerator. So that's why this is such that the denominator, you rationalize the denominator. So what's the conjugate of minus is plus. So I will write here as square root of x plus 2, which is the conjugate of x minus 2, over the square root of x plus 2. See it? That's the way to rationalize by looking for the conjugate. You use that conjugate to multiply both the numerator and the denominator. So I'll bracket the numerator, I also bracket the denominator. So I'm having lim x tends to 4, which is square root of x minus 2, the square root of x plus 2. I also bracket the denominator, x minus 4, square root of x plus 2. You see that? So what I will do now, I will open the brackets. I will expound the numerator. If that should happen, that will give me lim x tends to 4. So root x times root x will give us x. Okay? According to the law of solve, we have root m times root m. The result is m. Okay? So root x and root x is x. So root x times root 2 give me plus 2 root x. Then minus 2 times root s minus 2 root x. Minus root 2 times minus 2 times plus 2 will give us minus 4 over. I will leave the denominator the way it is. Root x plus 2. So let's see what we can do here. You will notice that my 2 root s minus 2 root s is 0. Those number will give us 0. So what am I having left? I'm having lim x tends to 4. I'm left with s minus 4 on the numerator over s minus 4 bracket root x plus 2. So you can see s minus 4 will cancel s minus 4. We are left with lim x tends to 4. 1 is now remaining in the numerator over root x plus 2. So it therefore means that anywhere I see s, I can put 4 now. So I'm having, so now it implies 1 over the square root of 4 plus 2, which is 1 over 2 plus 2. Our answer is 1 over 4. Is it clear? Understood?
Yes, sir.
Okay. If you have any question, you can ask.
Yes, sir.
On the contrary, you can write.
I'm done with here. I'm done with here. I'm done.
Okay. So these are to solve limits. Okay. These are to deal with limit and constant.
Yes, sir.
So from here, let me teach you. These are just preparation. Just we are not going deep. Let me teach you differentiation. Differentiation. Differentiation is also known as a derivative. Derivation is a derivative. I'm not giving you the top. I'm not going deep. It's a derivative of one variable, in respect to another variable. Respect to another variable. That's what differentiation is all about. Okay? Please write it. Okay? Are you there?
Yes, sir.
So are you done writing it?
Yes, sir.
So if y, they give you now y equals to f of x, meaning y is a function. This statement means that y is a function, of x. It means that if uh, if x don't exist, we are not going to have y. So y is dependent variable. Y is dependent variable. Yx is an independent variable. Okay? Y is dependent variable. Yx is independent variable. Please write it. It simply means that y depends on x to exist. Without x, there's no y.
I'm there.
Okay. So in differentiation, we have a formula. Your y is always x raised to the power n. The formula of differentiation. This is the expression for differentiation. Y equals to x raised to the power n. Okay. So if you prove this formula using first principle, then we have what we call first principle in calculus. So it means that your dy dx at the end of the day will give you nx n minus 1. So this is the formula of finding dy dx. Okay? Dy dx is nx n minus 1. Please take note.
I'm done.
Okay. So your n can be any number, can be half. Okay? It can be negative, any number can be negative 3, 1 over 3 can be negative 3, It can be positive 4, it can be 2, it can be 1. So n can be any number. Okay? So take note, n can be any number. So for instance, if you have y to be x to the power 3, we are asked to find dy dx. So if you go back, this is how you look like now. So what's our dy dx? Nx, n minus 1. So what this actually means is that if you want to find this is y versus x, that's why we wrote it, or we are writing it as dy dx. Are you seeing it? Y depends on x. Dy dx. So the formula is that this one will come down, which is 3. I will write my s back, then subtract 1 from it. 3 minus 1, according to the formula. This will come down, I will subtract 1 from it. That's how we have this. You see that?
Yes, sir.
So that's what. So if I simplify here, what am I having? 3x raised to the power 2. So if y is x cubed, your dy dx is now 3x squared. So write it. Okay. If you are true, let me know.
Okay. I'm true. I'm
Okay.
true.
Okay, all right. Let's see. Let's assume they give us y now to be, they give us y to be square root of x. For instance, we are asked to find dy dx. Now, if you look, when we express it, y is what? X raised to the power, is it not x raised to the power n? That's y. But if you look at this one, it's not like that. When we started, our y is written as what? X raised to the power n. Does this still look like this question they give to us? Because the n is not there, right? We just have x, but the n is not there, isn't it? Hello?
I am.
Now, does the question look like the original expression? The original expression say y is x raised to the power n. Does it look like it?
No.
Uh-huh. So how do we make it to look like this? So I can write this one as y to be x. Square root is known as half. Square root is equal to half. Are you there? Square root is something as half in power. So from here, I can now find my dy dx. So my dy dx now will give me, like we said, this power will come down to give me 1 over 2. I'll write back my s, 1 over 2. I will now subtract 1 from it, according to the formula, nx, n minus 1. So if you look, s over 1, you can take LCM here. So I will have 1 over 2x. My LCM is 2. 2 into 2 is 1. 1 times 1 is 1 minus 2 into 1 is 2. 2 times 1 is 2. So what are we having? My dy dx now will become 1 over 2x minus 1 over 2. Understood?
Yes, sir.
So, but if you apply the law of indices, law of negative power that says a minus m can be written as 1 over a raised to the power m, because of this negative power that we have here. So if I apply that law, what are we having? My dy dx will be 1 over 2 times, I want to apply the law now, 1 over x raised to the power half. See that? So up to up, down to down, what we multiply want to give me 1. Here's now 2x raised to the power half. Okay? half is square root we said earlier. So our answer is now 1 over 2 root x. This is not the value for our dy dx. Any question? Hmm? Any questions?
No question.
Okay, so write it.
I'm done, sir. I'm done. I'm
Hold,
done.
okay, hold on a minute. So, all right, let's continue. So what if they give us y? Give us y as l raised to power minus 3 over 2. Okay? X raised to power minus 3 over 2. Remember our y, originally our y is given as a xn. And when we wrote the y dx, I said the n should come down. I will not have n. I'll write my x, then subtract 1 from the power. This is the concept of the y dx. So this is y versus x. I'm going to have the y dx now to be minus 3 over 2. I'm bringing this one down. I'll write my x minus 3 over 2 minus 1. You see it? So yes over 1, like I said, you take LCM at the power. So this will give us minus 3 over 2 x. Our LCM is 2. So here becomes what? Minus 3 minus 2. So what are we having? My dy dx now will give me minus, minus 3 over 2 s minus 3 minus 2 is minus 5 over 2. You see it? So you can still apply the law of negative power here in indices. The law of negative power says a minus m written as 1 over a raised to power m. This minus sign here, only the minus sign here stands for this 1 over. So if I represent the minus sign as 1 over, what is left is a raised to power m. We've done that before in indices. This is just a reminder. So my dy dx now will give me minus 3 over 2 times 1 over x 5 over 2. See it? So our answer is now minus 3 over 2 square root of x raised to power 5. Because 1 over 2 is square root. So the answer becomes minus 3 over 2 square root of x raised to power 5. So that is the solution to the question. So write it. If you don't have questions to ask. Are you through with this part? Hello? Oh, you don't come on for network disconnect. Okay. If you're writing Post UTME engineering or physical sciences, you find this useful, stick to it, like, subscribe, and share. So this is our YouTube channel, STEMupAfrica. So we also deal with undergraduate courses like calculus, vector, uh, technical drawing, engineering drawing, computer sciences, among others. AutoCAD also. So stick to the channel for more important ventures. While we wait for the students, these are just basic concepts in very basic uh, concepts in differentiation and limits. And if you want one-on-one lectures with us, you can contact us through email or through our channel by making a comment on your, now put a comment in the comment section. I reach us through email.